Hello friends, I, Mrs. Anjali Shinde, Associate Professor, Department of Mathematics, S.V.K.T. College, FYBCom, welcome you all in this session. In the previous lecture, we have studied how to expand a determinant of order 2 and order 3. In today's lecture, we are going to see properties of determinants. So in some cases, without expanding the determinant, we can find the value of determinant by using properties. The first property is the value of determinant remains unchanged if its corresponding rows and columns are interchanged. That is, if you consider a determinant A1 B1 C1, A2 B2 C2 and A3 B3 C3 as its rows, then see, we will interchange this first row and write it as the first column. Similarly, second row as a second column and third row as a third column. In both of the cases, the value of the determinant remains same. So, interchanging the corresponding rows and columns, the value of the determinant remains unchanged. For example, if we have the determinant 1, 2, 3, 4, and now see, I will interchange its corresponding rows and column. So, I will write down this first row as first column and second row as second column. Observe, the value of this determinant is 4 minus 6, that is minus 2. And if you find this value, it is again 4 minus 6, that is minus 2. So, the first property says that the value of the determinant remains same if we interchange corresponding rows and columns. The second property says that the value of determinant is changed in sign only if any two rows or columns are interchanged. That is, determinant A1 B1 C1, A2 B2 C2 and A3 B3 C3, it is same as minus of determinant. Now I am changing, suppose, first and second row. So if you change any two rows, the sign changes with minus. So I will interchange A2 B2 C2 as first row, A1 B1 C1 as second row, A3 B3 C3 as third row. So observe, these two rows are interchanged here and therefore the sign of the determinant changes. Or even though interchange any two columns, suppose in this I will interchange any two columns. I will interchange first and third column. So I have to change the sign by minus. I am interchanging these two columns. So it becomes C1 C2 C3, B1 B2 B3 and A1 A2 A3. Observe that interchanging any two rows or any two columns changes the sign of the determinant. For example, suppose we are considering determinant 1, 2, 3, 4. If you interchange these two rows, then sign become minus. Suppose I will consider 3, 4, 1, 2. See, this value is 4 minus 6, that is minus 2. If you consider this value, it becomes 6 minus 4 minus 2. So, by sign change, if you interchange any two rows, even though you interchange any two columns, sign gets changed. If you write down this first column as second and second column as first one, even then the sign of the determinant will be minus of that. So, second property says that if you interchange any two rows or any two columns, then the sign of the determinant will change. The third property says that the value of determinant is 0 if any two rows or columns are identical or proportional. That is, determinant A1, B1, C1, A2, B2, C2 and A1, B1, C1. I am taking first row and third row to be identical. If any two rows are identical, the value of the determinant is 0. Or even though if any two columns are identical, A1, B1, A1, A2, B2, A2, A3, B3, A3. Observe that first column and third column are identical. So, obviously, the value of the determinant is 0. Or even they are proportional. That is, suppose we are considering 1, 2 and I will take some proportional of this. Suppose I will take 2 multiple of that. So, I will take 2, 4. Observe that second row is 2 times the first row. So, it is proportional, it is twice. In this case also, the value of the determinant is 0 because the two rows are proportional of each other or the two columns are proportional of each other. See, the second column, it is twice the first column. So, obviously, the value of the determinant is 0. So, two rows are identical or two columns are identical or any two rows are in proportion of each other. In such cases, the value of the determinant is 0. The fourth property says that multiplying determinant by a constant k is equivalent to multiplying any one row or column by constant k. This means that if you are multiplying a determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 by constant k, then this is equivalent to multiplying any row by k. So, it may be equal to, I am multiplying first row by k, A1, B1, C1, k times, then A2, B2, C2 and A3, B3, C3. So, we are multiplying the determinant by k, it is same as multiplying all elements of first row by k or second row by k or any column. Even though this is also equal to, I will multiply by k to first column. So, it is nothing but KA1, KA2, KA3. So, these are same because multiplying the determinant by k is same as multiplying any row by k or any column by k. That is fourth property. This gives us, we are able to take constant elements. Suppose I have the elements. Observe that I am able to take 5 common from the first row, and I can write down this as 5 determinant 1, 2, 3, 1, 2, 3, 5, 6, 7. So because I observe that the first row we are able to take 5 common, we can take 5 common and we get the determinant. Observe that these two rows are identical, so obviously value of the determinant becomes 0 because first row and second row are identical. So the property helps to find the value of the determinant without expansion. The fifth property says that if any row or column of a determinant can be expressed as sum of two or more terms, then the determinant can be expressed as sum of two or more determinants. That is, if I have determinant A1, B1, C1, A2 plus P2, B2 plus Q2, C2 plus R2, A3, B3, C3, then this second row is expressed as sum of two elements. So the total determinant can be expressed as sum of two determinants as A1, B1, C1, A2, B2, C2, A3, B3, C3 plus A1, B1, C1, P2, Q2, R2 and A3, B3, C3. Observe that the elements of second row can be expressed as sum of two terms, hence the total determinant can be expressed as sum of two determinants, or even though you express this as sum of more terms, it can be expressed as sum of determinants as given. So these terms can be separated and we get same answer in both the cases. So this is the property of determinants. The next property says that the value of determinant remains unchanged if we add k multiple of any row to corresponding elements of any other row. It is also true for column, so I can say row or column. So the value of determinant remains unchanged if you add k multiple of any row to the corresponding elements of any other row. That is, suppose I have determinant a1 b1 c1, a2 b2 c2 and a3 b3 c3. This is same as determinant a1 b1 c1, a2 plus k a3, b2 plus k b3, c2 plus k c3, a3 b3 c3. Observe that I am changing R2 row by R2 plus k times R3 row. The second row is interchanged by second row plus k multiples of third row. Even then the value of the determinant remains unchanged, or even though you do this in columns, it remains unchanged. For example, suppose I consider determinant 1, 2, 3, 4 and now I am considering operation R1 goes to R1 plus 2R2. That is, I am changing first row by adding to it 2 multiple of second row. So multiple of 2 becomes 6, 6 plus 1 becomes 7, twice multiple, that is 8, and 8 plus 2 10. If you consider this determinant, observe that it is nothing but 28 minus 30, that is minus 2, and this determinant is also minus 2. Because we are adding 2 multiple of second row in first row, the value of the determinant remains unchanged. The same happens in column also. So that is the next property of determinant. One of the important property of determinant is if all elements below or above the principal diagonal are 0 in a determinant, then value of determinant is product of diagonal elements. That is, if I have determinant a1 b1 c1, 0 b2 c2, 0 c3. Observe that below principal diagonal, this is principal diagonal, below this all the elements are 0, and if you expand this determinant, it is nothing but product of diagonal elements. So the answer comes to be a1 into b2 into c3, the product of diagonal elements, because all the elements below the, or even though if you consider a1 0 0, b a2 b2 0 and a3 b3 c3. Observe that above the principal diagonal value is 0, even then the value of the determinant is product of diagonal elements, that is a1 b2 c3. This is the value of the. These properties are very useful to find the value of the determinant without expansion. So in some cases there is no need to expand determinant, we can use the properties and simplify the answer. For example, suppose we want to find the value of determinant (30, 60, 90, 100, 200, 300 and 130, 260, 390. Observe that if you go on expansion, it will take time. But if we have keen observation, the third row is addition of first and second. So, if I want to find the value of determinant, I will do the operation. I will change R3 to R3 minus R1 plus R2. So, I will add R1 and R2 and subtract it from third. That is my third row. So, what is D dash? It becomes 30, 60, 90, 100, 200, 300, and I am from R3, I am subtracting the addition of first and second. 30 plus 100 is 130, 130 minus 130, 0. 200 plus 60, 260, 260 minus 260, 0. Similarly, this will be 0. And because one of the row, all the elements of one row are 0, obviously the value of the determinant is 0 because total row is 0. So, by observation, you are able to get that the value of the determinant. So, what we are using? We are using the property that if you add some k multiples in another, the value of the determinants remains same. You can check, you can use any property. For example, suppose that any student gets the idea that from the first row, we are able to take 30 common. So, he will write down the determinant as 30 common from the first row. It will get 1, 2, 3. Similarly, take 100 common from second row and we will get answer again 1, 2, 3. Observe that because the first two rows are identical and we know that if the two rows are identical, the answer value of the determinant becomes 0. So, you can use any property and show that the answer, the value of the determinant comes to be 0. Now, without expanding, prove that determinant A, B, C, X, Y, Z, P, Q, R is same as determinant Y, X, Z, B, A, C, suppose we want to prove this. So, start with LHS and use the property of determinant because we want without expanding. So, do not expand, use the property of determinant and prove that. So, consider LHS. It is nothing but determinant ABC, XYZ, PQR. We know that if you interchange any two rows or columns, the value of the determinant changes in sign. But if you interchange corresponding rows and columns, the value of the determinant remains unchanged. So, I will interchange rows and columns. So, what we are doing? The first row, I will interchange as the first column. So, the value of the determinant will remain same. First row becomes first column, second row becomes second column, and third row becomes third column. The value of the determinant remains same if rows and columns are interchanged. These are corresponding rows and columns. So, the value of the determinant will not change because corresponding rows and columns are interchanged. Now, observe that I will interchange first and second row. I will have minus sign because if you interchange any two rows, we will get minus sign. So, interchanging first and second row, we will get BYQ, AXP, CZR. We are changing first and second row, the sign changes. Now, observe that we want Y and B interchange. So, I will interchange first. So, this is R1 and R2 I am interchanging. First and second row are interchange, or it can be written as R12, that is interchange first and second row. We get this one. Now I will interchange first and second column. Again sign changes because we are interchanging two. So I will either interchange C1 and C2, or we can write this as C12. That is interchange first and second. Because we are interchanging column, the sign changes. So minus become plus. Determinant Y, X, Z, B, A, C, Q, P, R. Observe that it is nothing but RHS. So we get LHS is equal to RHS, that is without expanding. Using the properties of determinant, we have proved that both sides are equal. Without expanding, prove that determinant 1, 1, 1, A, B, C, B plus C, C plus A plus B equal to 0. So we don't want to expand. We will use properties of the determinant and prove that this answer is 0. So consider LHS. It is nothing but determinant 1, A, B plus C, 1, B, C plus A, 1, C, A plus B. Now I will change C3 column by C2 plus C3. So in the next, we know that if you add k multiples of any column to other column, the value of the determinant remains unchanged. So I am doing the operation C3 will interchange to C2 plus C3. So we will get the third column only gets interchanged and it becomes the addition of this. So it is A plus B plus C, B plus C plus A and C plus A plus B. Because we are changing C3 and C2 plus C3. Now observe from third column, we are able to take A plus B plus C common. So I will take this common, A plus B plus C common from third column. It becomes 1, 1, 1, A, B, C, and this becomes 1, 1, 1 because A plus B plus C is everywhere. So it common gives. Now the two columns are same, are C1 and C3. They are identical, and if two columns are identical, obviously the value of the determinant is 0 because C1 is identical to C3. As first and third column are identical, the value of the determinant is 0, that is nothing but RHS. So without expanding, by using properties, we can show that the value of the determinant comes to be 0. Consider more example. Without expanding, show that determinant A minus B, B minus C, C minus A, B minus C, C minus A minus B, C minus A minus B, B minus C, 0. Suppose we want to show that the value of this determinant is 0. So start with LHS and use the properties. The property, if you do the observation, you will get the idea that see A minus B, B minus C, C minus A. If you add these three, we get 0, and therefore I will change this first row. I will change R1 to R1 plus R2 plus R3. The value of the determinant remains unchanged. So what is it? R1, that is A minus B, plus R2, that is B minus C, plus R3, that is C minus A. Similar everywhere. B minus A plus C minus A plus A minus B, and B minus A plus C minus A plus A minus B, and lastly C minus A plus A minus B plus B minus C. What we are using? We are changing R1 to R1 plus R2 plus R3. The other row remains as it is: B minus C, C minus A minus B, C minus A A minus B, B minus C. Observe that all these gets cancel and we get the first row to be 0. And we know that if any row of the determinant is 0, then value of the determinant comes to be 0. And therefore, one row is 0 implies that the value of the determinant is 0. So, by keen observation, we will able to use or apply property. Which property we have to use, that depends on the example. Take one more example. Without expanding, prove that determinant x square, y square, z square, x, y, z, 1, 1, 1 is equal to x minus y, y minus z, z minus x. We want to prove this. So, start with LHS. Determinant of x square, x1, y square, y1, z square, z1. Observe that we want to find the factors x minus y, y minus z, z minus x. So, we will use the property. I will interchange R2 to R2 minus R1 and R3 to R3 minus R1, because we know that the formula y square minus x square, we know the formula a square minus b square is nothing but a plus b into a minus b. So, if I take y square minus x square, I will get the factor y minus x, etc. And therefore, we will apply this rule. It becomes x square x1, y square minus x square, y minus x, 1 minus 1, 0. Similarly, R3 goes to R3 minus R1, it gives z square minus x square, z minus x, 1 minus 1, 0. Now, y square minus x square is nothing but y square minus x square is nothing but y plus x into y minus x. So, what is this determinant? It is equal to determinant of x square x1. Here the factor is y plus x into y minus x, 0, z square minus x square means z plus x, z minus x, 0. Now, from the second row, we are able to take y minus x common, and from the third row, we are able to take z minus x common. So, the same example now becomes equal to y minus x common from second row, z minus x common from third row remains x square x 1, y plus x 1, 0 and z plus x 1, 0. Now, if you interchange any two columns or any two rows, the value of the determinant changes by sign. So, you can either interchange this and take. So, we can have sign change. I will interchange first and third column. It becomes y minus x, z minus x, determinant of 1, 0, 0, x 1, 1, x square, y plus x, z plus x. Because we are changing first and third column, the value of the sign, value of the determinant changes by sign. It becomes minus sign. And now we are able to expand the determinant, which is simple. So, by direct expansion, we get y minus x into z minus x determinant. See this value, the value comes to be 1 into bracket 1 into z plus x minus y minus x, x into 0 and x square into 0. So, it becomes minus of y minus x, z minus x into z minus y. It is nothing but we want the answer to be x minus y. So, I will change this sign, x minus y into y minus z, change the sign, y minus z into z minus x. This sign becomes minus minus, so it becomes RHS. So observe that I am taking minus sign common from this also and this also, so it becomes x minus y, y minus z, z minus x, it is nothing but RHS. So without expansion also we are able to find the value of the determinant if you use the properties of the determinants. So today we have seen some properties of the determinant. Without expanding we can able to use the properties and find the value of the determinant. In the next lecture we will see matrices and types of matrices. Thank you.